The interpreter you wrote doesn't do with semicolons or with braces or anything like that. It simply has all the information that you need in it. And so the point of parsing is to be able to take the Patina program and convert it into something of the proper type. So some sort of expression type or program type that contains all the functions that you need. And that from there on, you can take this list of functions and you can compile, take each of them and convert it into different representations. So we may or may not be doing an intermediate representation where you take the abstract syntax tree, you convert it into, for example, there's something called single state assignment SSA form, where you convert a function into a bunch of different blocks. So you might not be doing that, but you will be using the AST for the type checking. So for example, if you're given just a text file, I'm going to try to turn on the computer here so I can go to the reference to talk about what we were, talk about the language. So the goal is to have, well, hopefully you've seen the website, read through the website maybe. You don't have to have, because we haven't talked about it yet. But the website does have sections for each of the different things that are contained in Patina. So I think I'll write this on the board, I guess. There are three important things that Patina has in it that you're going to need to be taking account of, and they will be where the challenges are for when you're writing all the different steps of your compiler, from the arrays to the functions, from type checking them to actually turning them into bytecode. So those three things are, well, I said one of them is the arrays. So the arrays in Patina are very different from arrays in most languages, in that they only contain ints. You can't have arrays of arrays. Second, they have a particular type. They have a particular length. Yeah?
Are we going to be coding in Patina from now on? Or?
No, you're compiling in OCaml about Patina.
Oh.
So this is actually, Patina is based on Rust. Do any of you know what Rust is? Some of you? So Rust is a low-level language, relatively low-level language like C, where you're working sort of directly with addresses and stuff. But unlike C, it has all these safety features built in. And we actually don't have any of those safety features. We're just taking its syntax. And conveniently enough, the syntax of Rust and a lot of its features that don't have to do with safety are actually taken from OCaml. So part of the reason of having the first assignment where you're writing in OCaml is not only to give you practice with OCaml, but also to familiarize yourself with some of the things which are specific to both Patina and OCaml. Anyways, one of those things, actually not one of those things, is arrays, where the arrays are of some particular length. So you can call alloc, which is like malloc in C, where you say, I want a certain amount of memory. And then from then on, you have that amount of memory. It's dynamic. So in contrast to, okay, so some functions, let me think. I'm going to write in Python, even though that's totally inappropriate, because, well, I won't make any mistakes that way. So if we have some function where, let's say, we're going to be taking the first thing that it's divisible by, integers up to of integers. So basically, we're going to check if it's prime. If it's not prime, we're going to give it smallest factor other than 1. So if I write something like this, And let's say at the beginning, I only care about the small factors. So 2 through 7, I guess. So then I could say, I could write V1 is equal to n mod 2 equals 0. Right? That makes sense? So B1 here is statically allocated because B1 takes up the exact amount, same amount of space every time the program is run, and regardless of what the input, whatever this n is, right? So this B1 is static. However, lists can have dynamic, arrays can have dynamic storage. So here, if I instead did, I guess, the Python way of doing this would be to say factors is some big list, where I say for f in range, whatever, So this thing here, because there is a variable amount of items in the list, is dynamically allocated. So this is one of the big things that Patina has that will be some amount of trouble for you in the, or it might be. Maybe you'll just breeze through everything. I hope so. But it's one of the things that could cause problems. And these arrays are, yeah?
Do you have a darker marker?
Good question. So these ones, I think I tried and they don't have it. I bring around some markers with me. I'll see if those work.
Thank you.
Yeah. Let's see. How's that one? This red one. Sure. That better? I can also, I guess I'll have to do something like this. I can also use the computer and type things. So here, if I go to whatever, find something. All right, so some of these are not going to actually be valid OCaml. So maybe I do want a pirate pad for that or whatever. Here we go. Hopefully this works. Okay, so we have arrays. The first difficult thing about Patina is the arrays. And these, you'll notice if we go to our Patina reference, you'll notice that, give me a second. Here we go. You'll notice that these arrays have type of square brackets around an int. So can you guess what that means? So if I say some value has type this, what does that mean? It's an int array. What else? You don't.
Array with the value.
No. So good guess though. Yeah, this is 4 elements. So our arrays, they have a specific type corresponding to their length. And this type is actually dynamic, it changes depending on what values got passed in. So that's one of the interesting things about Patina. And you'll notice that when we have a let expression down here, this is the syntax. Does it look familiar to the sort of things you've seen in class? Yes, no? Okay, good. So down here, you can see most of the expressions here don't actually require types. So the list of parameters does, and so does the function. But other than that, the expressions mostly don't mention type, except for this. So let ID colon type equals. So this is actually similar to what you can do in OCaml. So in OCaml, you can say, let x equals 5. This is okay. But you can also say let x colon int equals 5. And in this case, using the colon is not actually useful because you know that 5 is an int. But as you might have encountered when coding, a lot of the time you run into type issues where the type that you're giving as an argument to a function doesn't match the type that you think you're giving to the function. And in these cases, it's useful to use this colon syntax where we say, okay, I'm declaring that this value that I've written is of this particular type. And in Patina, you have to do that every time. So you have to say, let ID of some type equals expression. So here, let's say we're just trying to say something is, we're trying to declare true, a variable to be true, say x. How would you write that in Patina? Yeah. Great. Does that make sense to everyone? Okay. Yeah, we want to, but what if we have an array? What do we do in that case? If we're defining something, let's say it's equal to, we have our array, which is alloc of 7. And we want y to be equal to this. What do we type for in Patina? Yeah. Let y equals y colon int of 7 equals this. Okay, I think that's pretty close. You just say this. Yeah. And let me check if there's and we also need a semicolon at the end. Oh, maybe that's actually the case. Maybe we don't have this dynamic type. Okay, actually, I think you might be right.
Yeah.
I think we have this. Yeah. So we have this, the type of it is an int array because that's what it has to be. But so the space it takes up is dynamic, but I was wrong. The type itself is not dynamic, which will be good. As I was saying that, I was like, I'm not sure how you implement that. But good. So we have an int array, and this way, when you do type checking, you can check whether if we have ID of expert, let's say expert is just a constant, then if we have something of type R of 6, then first of all, what's this type? This is int. And what's this one? Yeah, what type is it? Yeah, it's an int array, just like this one. So we have to, the usefulness of having these type annotations is that, well, we know what type this variable is now. And so we can always know what every type of our variables are. And then when we're assigning them, we can make sure that this type that we have, that the type of the expression is actually equal to the thing that we say it is. So whereas in OCaml, you write your code and the compiler helps you out by telling you, here's where you have a type mismatch. And so you can fix your code so that it no longer has this type mismatch. For Patina, when we're writing the compiler, we're fixing that problem itself. We're giving the advice about types and stuff. So, and in order to do that, it'll be easier for us that we have this particular requirement, that whenever we let some variable equal something, we get to know what type it's supposed to have. Yeah. Okay, so what else is there here? We have sequences. This is similar to what you did. This is also similar to OCaml. So in OCaml, if you just have some expression and then a semicolon and another expression, then that evaluates to whatever the value of the second expression is. So you can see that here, if I type in, say, 5:6, okay, whatever. So there's a warning because it's expected to be something print, but whatever. You can say, let x equals 5 in this, and then 6. Now there's not a warning anymore. And still, oh, different warning. And still the value is equal to the last thing. This is similar to what you did in homework. So the sequencing is the same. We have if branching, it's pretty much the same thing. Again, the things that happen inside this if don't actually influence the variables that are outside of it. So we look at the reference here. The things that come inside the ifs are themselves sequences. So arrays are one of the difficult parts. The other difficult part is the functions, the fact that there's more than one function. So when you were writing the interpreter before, for both problem 2 and problem 3, you're just evaluating an expression, which is just a series. Here's a bunch of things that happen, or just a single thing, whatever. But with functions, some of what is to be done, you don't know when you're compiling. And this is, I guess, the big difference between compilers and interpreters. For an interpreter, you can just take whatever you're given, and almost always you can just immediately evaluate it, figure out what's there, pass it in. You can just eagerly get what everything evaluates to. For the compiler, you're writing instructions that are going to, where what they do depends on what the value is, and you don't know what the value is yet. And this is particularly clear in functions. So the way that, I guess you've all written plenty of code, you know what functions are. You know that programs have multiple functions in them. I'm not actually sure if we have a main function here, where that's the one that gets run, but it looks like according to the syntax, we don't have it. I'll ask Junrei about it later. Okay, anything else about, okay. So if we have a, let's try writing some functions, I guess, in Patina. So if we want to do my smallest factor thing, or then what's a way that we can do this? Maybe we want to take, want to just calculate all of the factors of some integer and just return those. One question is it possible to do that using the syntax, which, let me double check. I'm going to pretend there's a mod thing in here, but you can construct mod out of these, I'm pretty sure. Yeah. Anyway, so pretending there's a mod in here, let's try to write a function which takes in an integer and returns an array of all the factors of it, using only the syntax plus mod. So there's a difficulty here compared to Python. What's that difficulty? Our array, yeah, the arrays, you can't just append things here. We don't have any lists like we can, or like, I guess, playlists in Python, in Java. So what can we do? This is just a coding exercise, get used to how Patina works. So let's see, let me get the syntax exactly correct. We want to say fn of factors of n, which is an int, and we want to return an int array like this. And now, what do we have here? You said you make it a new array?
Our goal is to, our goal is to make the array bigger.
We don't have an array yet. We have an int.
We want to add it to the list.
No, we want to create a list of integers, which correspond to the factors of the number.
Oh.
I'm choosing this one because it's pretty easy to do if you're just doing it in Python, but here it requires a little bit of working. Yeah.
So you start like one. Well, is there like floating numbers in this language?
No floating numbers.
No float. There's start with one, and then you make an array. One element. Every time there's a new packet that's found that you can successfully divide it, you make
So what should I put here?
one.
Okay.
Well, here's the fun part. You every time you want to append, you want to make a new array, and then you copy the elements over. Like new array that's one size bigger.
Okay.
Copy the elements. So in effect.
Does someone else want to explain how I translate your explanation into code? So I have a size equals 0 maybe. Now what? Or equals 1. Okay. Yeah, we could do that. Okay, I don't have to actually write out the whole function if people understand. Does anyone want me to go through with this?
Awesome.
Yeah. Oops.
Remember, Anderson camel is mutable. So this array also immutable.
No. So
Array is an exception.
arrays, this isn't OCaml. Everything in OCaml is immutable, essentially. There are references, but that's an exception. But Patina is not that. So you can see you can mutate using this standard syntax. This is similar to
You keep mentioning
C.
the keyword like array is dynamic. Does that dynamic is the same definition? Mutable?
no.
Change this.
No. So I say it's dynamically allocated. Dynamic means, essentially dynamic means the compiler can't figure it out. And static means the compiler could, in theory, figure it out. Where if it's dynamic, then in order to figure it out, you have to run it. And in order to figure out the size of an array, which is actually one of the things that we have here, this int array that we return, we don't know it at compile time because it depends on what our n is. If our n is 2, then it'll return a list that's length 2. If our n is 10, I guess then that's more, 4 or something.
Basically, how we know the runtime.
Yeah.
This is the syntax.
This right here, I'm pretty sure you can correct me like with the other thing, but I'm pretty sure this is the syntax of Patina. So you can see all the lets have their types attached to them. You have a semicolon at the end of every line, except for the last one, because the last one is just what it actually is.
You don't have to begin it.
I don't see any begin and end here, so.
Yeah.
So this doesn't tell you anything about precedence and so on, which I'll get to later on, but we'll have that in the assignment description. So this doesn't tell you if you have, say, Let me see if I can think of a case where it would matter. I guess easily, you could say, if we have something that looks like 9 times 2 minus 3, what does this return? I guess it makes sense to us that it would return 18 minus 3 is 15. But in this definition here, it doesn't quite tell us that. We have to also say, what is the precedence of each of these operations? And are they different from each other? Because if we had, say, 9 times 1 less than 2 times 3, if you have the precedence different here, you get different results. So you've probably seen people have these like PEMDAS arguments online. We're going to make sure that all of that is fully defined before you have to write a parser to get it. Because like if you did this left to right, then that's not quite right, because we want this less than to have lower precedence than the other two. We want to say 9 times 1 happens first, and then 2 times 3 happens, and then you compare them. But apart from that sort of thing, the syntax is this is the description of what the language looks like. Yeah. This is the syntax of Patina, not of OCaml. So one obvious difference is in OCaml, you say let rec. Here you say fn. Patina, in OCaml, you have let something, let variable equals expression in. Here we have let variable equals expression semicolon. That's some differences. In terms of substantive differences, we can say here, we can say R of 0 is equal to 1. I think we can say that. Yeah. And in OCaml does have things to work with like arrays, but they're not the basic stuff available. And it is basic in Patina. So you're expected to be working with arrays here. And these arrays are mutable. So if we put this inside of a sequence, if we put this like this here, then and then we look at R0 afterward here, if we I guess we just return R0, then we are going to be returning 1, even though the scope, because R is in scope because it was declared out here, and this is not a redefinition of a variable. A redefinition of a variable would not be in scope, but this is a change to a value, to an array. And so when the result is, when it's returned, it will still have this value in it. And unlike, so Patina is different from most languages in that Patina doesn't care at all about memory leaks or whatever. Once an array is defined, it exists forever until the program finishes. So you don't have to worry about freeing, you don't have to do garbage collection. It doesn't do, yeah. Yeah. It's not a feature, no. But the point is to make it easier to write a compiler. Because if you take a complicated language, then you're in the quarter system and like you don't have time to do anything like super complicated. So this will be hard enough, I expect. Yeah. Mm-hmm.
Like all the list of arrays, columns of the array are mutable.
Yes. Which is why I got confused for a bit about the type here. Yeah.
So just to reiterate, a sequence in Patina doesn't work the same way in our homework where if everything in the sequence is not in scope.
It does work the same.
Okay.
So if down here I said, for example, if I said let R of int equals alloc of 2, for 1, this is legal. For 2, when this change happens, it's modifying this array. And so when you look here, this array is the one that was declared up above of length 1. And so this will still return 0, but this will return 1. Got it? Let me see if there's anything else.
Create an array with all values, the array on addition.
What?
Create an array, all values itself is array on addition.
That's a good question. I think so. What that ends up, the difference that this ends up making is whether you're going to end up calling malloc versus calling calloc or whatever. And that comes much later in the course when you're actually translating this into a lower level assembly or whatever. So for functions, functions sort of have the scope built in, yeah?
So all arrays in PR are dynamically on only the array out, right?
Yes. There's no, you're not allowed to say, for example, let me see. You can't say let R int equals or whatever. So this is something you can do in most languages, but you can't do it here because we didn't define it. And so that's one less thing for you to have to compile. You can do this in OCaml, yes. Although in OCaml, it's sort of shorthand for, this, right? This is now OCaml, this part, not Patina. So what's on the right here, if it's anything new, it has to be an alloc. But you can also, you can say like, let R2 is equal to R or whatever. There's not much point in it, but you can do it. And in this case, they are pointing to the same, they're pointing to the same memory. And so you have two different variables pointing to the same space. So maybe if you change one, if you modify the array of one variable and you come back to the other one, you'll notice that something's changed. So that restricts the sort of optimizations that you're able to make to the speed of the compiled code. Tail recursion, did you go over tail recursion in class? Yes, okay. So that's an optimization. We can have, if we have our function, return the function applied to something else, then that goes faster. Let me think. Yeah.
AR2 is to go the function web AR.
So ARR, they're both pointers, I guess. They're both references to arrays. So it's not that AR2 is at a higher level of abstraction from ARR. They're the same type. They're both int arrays. Yeah, so here if we say AR2, and then this thing is going to be 1. So we have arrays, functions, precedents. So for when you are writing, the parser, most of the parser is going to be easy, but there are a couple of cases, especially when things are right next to each other, that they can be confusing. These unary expressions in particular. The fact that the IDs can be used as expressions and they can also be used as functions. But whenever they're used as functions or as arrays, you can always just, they're always next to something else that tells you, okay, that's what it's being used for. Instead of being just a variable. So that should make it easier as well. Have you talked about, I guess, parsing in particular? You've talked about context-free grammars, which is this a context-free grammar? I think it has context in it. Let me think. Do you remember the definition? So some of these things are. Well, so the point of having the context-free grammar, being able to translate it into a push-down automata, the push-down automata is what lets you do the parsing. It's not I guess, an inherent feature of the language. It's just a fun thing that if your language satisfies these constraints, you can write this sort of program to parse it automatically. And so for that, you're going to be working probably with YAC. And OCaml actually has these lexer and parser generators. Have you seen anything like this before? Okay, so OCaml lex. So there's lexing and there's parsing. Do you know the difference? Okay, lexing is when you take we take this entire string and we say, okay, this is all one thing. This start here is all one thing. It's some arbitrary string, but it is one thing. Whereas factors, this thing here, can be separated into being factors and then a parenthesis and then an n and then a colon and then an int and then a close paren. So lexing is really important because otherwise maybe you'll think this whole thing is a string, is a variable name. You have to be careful about that. So lexing is also easier than parsing, I think. So the difficult part maybe is quotes, but I don't think we have any comment strings here. Yeah, we don't have any comment strings, and those are the most difficult part, I think. So you have some sort of relatively simple lexer, and then we have a parser, and you're basically going to be writing something that looks like this grammar, but instead of for the parser, but instead of having just these things, you also say, okay, what is the value in the AST that corresponds to this thing? So here you could say, okay, what's the if we're trying to compare this to patina arith, then what value does int const correspond to? Yeah, so wait, int const would then correspond to const of whatever int it is. And so the way you'd write it is you say, okay, we take whatever this thing is, we take its value, and then we apply const to this whole thing. But I'll apply const to the first thing in this list. And similarly for the rest of them. So this is again, normally it's easy, but then precedence can mess things up. I haven't written it yet for patina, so I don't know exactly which things are tricky in this case. But for the most part, parsing is mostly really easy, but then some weird things happen. And you can see here, we have, wait, is this the right one? No. Here's where you declare whether something, which way precedence goes, which way things associate. You're going to need to, these things can again be mostly copied from whatever we hand out in the assignment definition, because we will define them for you. But yeah, so each of the rules has some number of symbols, where the symbols correspond to non-deterministic in things in the context-free grammar. Or I guess they could also end up being the endpoints. So we have those symbols, and then given those symbols, what are you going to do with them? I'm going to see if I can. Oh, good. There's an example here with arithmetic. So you can see we have this lexer, very easy. we case on the token essentially. And just say, okay, when you see a left paren, it's a left paren. When you see the end of file, we say it's the end of file. Nice and easy. This part is. This is the hard part, where we say, okay, when we have a list of numbers, digits in a row, then we want that to be a number. And we want to just immediately calculate what the number is instead of leaving it as a string. And then the parser is somewhat more complicated. These dollar signs are correspond to number 1 is equal to this expression. So when we say, this actually isn't even a parser. This is just a, or it's sort of a parser. It does everything for you. So if we were doing this for patina arith, instead of saying $1 plus $3, instead we would say it's binary of add of $1, comma $3. Does that make sense? Because we're not doing any, the parser shouldn't be doing any of the calculation besides like we read a constant int and we say, okay, here's what the constant int is. But like apart from that sort of thing, all of the actual calculation should be done after you've compiled the code and you're running the code now. So we don't do this addition and subtraction and stuff here. Instead, we put that into the language that into the abstract syntax tree representing the language that we're writing. Okay. Any questions about this? Though this is, the deadline for this is like a long time off, but any questions anyways? Yeah.
So when will assignment 2 be ready?
Tomorrow? Yeah. How's assignment 1 been going? I haven't counted the number of submissions. Is it hard? Yeah, it was due yesterday. If you turn it in late, two days. Anyway, I think it's good to not use it on the first one if you can avoid it, but use it on the last one. Or that's the part that's always been the hardest for me is the x86 assembly itself. But different people are good at different things. So anyway, I'm done here. What? I mean, whatever comparative advantage, whatever.